Hi class, so we are right in the middle of part of 9.1. This is going to be part 2, and we were talking about radians versus degrees and how to convert from radians to degrees. So if we have radians, and it's based on this right here, if we write in radians after this, our radians times 2 pi are equal to 360 degrees. If we divide by 2 pi and get rid of the 2 pi, then you're going to notice that our radians are equal to, because the 2 pi's divide away, radians are equal to our degrees, right here, the degrees, you see the degree sign right here, times pi over 180 degrees. So if we divide out a 2, we get 180 degrees. So it's all based on this formula in the beginning. You just are going to solve for radians. And based on this formula, we're going to solve for degrees. So if I have degrees, then it's pi radians divided by, or times by 180. So anyway, that's how we're going to convert. I am going to erase all this and then just write out the formulas again because I want to make sure that our formulas are understandable. So 360 degrees is 2 pi radians, and 180 degrees is pi radians. Okay, so with those formulas, we can most definitely, I don't know what that just did. I gotta learn my little new toy here. So if we're going to convert from degrees to radians, so when you see converting to radians, notice that you have degrees already. So we have 30 degrees, and with the 30 degrees, we're going to convert into radians. So we're going to use our formula that we see right here. Okay, so if we want radians, then we're going to take degrees and we're going to times it by pi radians over 180 degrees. Now, the degrees in radians I'm not going to worry about. What we're just going to do is multiply by pi over 180 degrees. All right, so what that does is that takes your 30 degrees is on top because you multiply straight across, 30 degrees pi over 180 degrees. And you notice that these degrees divide out. No longer do we have degrees, which is a sign that we are dealing with radians. And this becomes radians. And then your zeros divide out. And you can divide out a 3 from the top and get 1, and a 3 from the bottom and get 6. So we have on the top, we end up going across with 1 pi. And we know we don't need to write the 1. We just know it's 1 times pi is the same as pi. And then on the bottom, everything's gone but the 6. And that's what we have is pi over 6 when we convert. All right, 150 degrees, again, we do the same thing. We multiply by pi over 180 degrees. Once we've completed the multiplication, we multiply straight across to get 150 degrees over times pi over 180 degrees. The degrees divide out and we're left in radians, pi radians. Our zeros divide out, and then we also look for common factors, which in this case are 3. 3 into 15 is 5, and 3 into 18 is 6. So what we end up with is on the top we have a 5 and a pi, and on the bottom we have a 6. And 5 pi over 6 is the same thing as 150 degrees. And then negative 220 degrees, again, in radians will be pi, we multiply by pi over 180 degrees. Multiplying straight across, we have a negative 220 pi over 180. All right, the degrees divide out and the zeros divide out, and it looks like we have a common factor of 2, which leaves us with negative 11. Negative 11 pi over 2 and 18 is 9. Negative 11 pi over 9. All right. And those are degrees turning into radians. Now, I did want to show you one little thing here, and that is what are all these little pi over 6 and 5 pi over 6 and negative 11 pi over 9. Now, what happens is we know that as we're moving along, right here is pi in radians. That's pi right there, right? Because that's one radius length, another 3.14 radii lengths across, from the initial side over to that part right there that we find pi. So if that is so, and it is, we have to understand that when we see pi over 6, that means we're breaking pi, this area right here, into 6 equal parts. And pi over 6 is just one of those 6 parts. So I always like to think 1, 2, 3, 4, 5, 6. That's 6 parts. So right there is pi over 6. That's 1 pi over 6. My next one was 5 pi over 6. So I go 1, 2, 3, 4, 5, 5 pi over 6. That's 5 pi over 6 right there. Now, pi over 6 we know to be 30 degrees, right? That's what we originally started with. Is that pi over 6? Is that 30 degrees? Yeah, it's about 30 degrees. So 30 degrees is the same as pi over 6, which means that I've broken up all the distance from 0 to pi into 6 equal parts and then traversed one of those 6 parts. And then 5 pi over 6 is I'm going to break it up into 6 equal parts and take 5 of those. And that says 5 pi over 6 is 150 degrees. 150 degrees is 30 degrees away from pi. So, yep, that looks about right too. Now, the next one is negative 11 pi over 9. So I'm going to erase all of this. Negative 11 pi over 9. And once that's all erased, then I can break it into 9 parts because the denominator is 9. I want to go in parts of 9. I want to traverse 11 parts of 9. So if I break these up, if I start here and I'm going in the negative direction, right? So I need to have 9 equal parts to get to 9 pi over 9. Negative 9 pi over 9 is just pi. So right there is negative 9 pi over 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I need to go 2 more. All right, and to make 11. So that right there is negative 11 pi over 9, which is what we were asked to find on the third one. So I just wanted you to see negative 11 pi over 9 is at negative 220. Well, we've traveled 180 plus 40 more. So that's about right. And that's why radians, or that's how radians are the same as degrees, and that's why we can convert between the two, is because we can see easily that the two, the radian and the degree, are equal. It's having some kind of lag or something. I don't know what's going on here, but hopefully it stops. All right, now the next one is 11 pi, 4 pi over 3. So when we have 4 pi over 3, what we're going to do with that is we're going to multiply by 180 degrees over pi radians. Now, if I do that, if I multiply by 180 degrees over pi radians, and we don't write the degrees of the radians, but in that case, what you notice are the pi's divide away. And because up here we said 180 degrees is equal to pi, with the pi's dividing away, in both cases, what I like to do is just replace the pi with 180 degrees. All right? Because that's what you're essentially doing every time, because pi is 180 degrees, and you get rid of the pi and put in 180 degrees, and that way you have your actual degree equivalency to your pi's. So 3 goes into 180 60 times, and then 4 times 60 is 240, and now we've gone from pi's to degrees. Right? Now, 4 pi over 3, that means I am breaking up pi into 3 parts. So 1, 2, 3 to pi, and then I want to go one more. And that is going to be 4 pi over 3. And so they're just fractions of the circle when you're dealing with pi's. Or is that 240 degrees? Yep, there's 180, and we go, that's going to be about 240. So here's 270. This is 240 degrees, which is the same as 4 pi over 3. All right, the next one, again, when we're converting from radians to degrees, we replace the pi with 180 degrees, and then we divide. Now 36 goes into 185 times, so we get negative 25 degrees. Right? And then 7 pi over 4, again, we're going to replace pi with 180 degrees. And 4 goes into 180, 90 times. And then, wait, it doesn't go in 90. Let me use my calculator. Is it? No. 180 divided by 4. It's 45. It's like, no, that can't be, that's too much. 45. So we're at 45. So it goes in, 4 goes into 180 45 times. And 7 times 45 is 315 degrees. All right. So that's how you're going to convert all of those. Remember, too, I'm going to just show you on the, I guess there's a little bit of a lag I need to be aware of. So if I break pi into 4 parts, so 1, 2, 3, 4, and then I have to go 7 more of those same distance, or 3 more to get to 7, 5, 6, 7, it's just about right there. 7 pi over 4, then that's traversing that amount of space, which in that angle, when it's 315 degrees, that's about right. So 315 degrees has the same terminal end as 7 pi over 4. All right. Okay. Let's see what we have next. I have a couple more minutes until I have to stop the video. See what we can do. All right, coterminal angles. You know what? I'm going to stop and we're going to just deal with coterminal angles next on the next video. All right, now click on part 3.